to another nervous system question. It says that figure 5.1 is a trace that shows the changes that occur in the membrane potential. It's about the changes of a neuron during the generation of an action potential. You're then given a graph where you've got different sections labeled A, B, C, D, E, and F. You've then got a series of questions that are regarding the points. So it says using letters A to F, which relate to the A to F on the graph, indicate the point or points. This is important, point or point, so it could be more than one, that correspond with the following. And then we've got hyperpolarization, resting potential, the membrane is most permeable to potassium ions, and depolarization. So going back to the graph then, the first point then is hyperpolarization. Well, hyperpolarization is when then it's below, the charge is below normal. So the normal is -70, so the point where it's below -70 is E. Resting potential is where there's no action potential, so what it normally is, all right, when the cell is resting. So on this graph, it's at -70, so we've got A, but we've also got point F, so it's A and F. The membrane is most permeable to potassium ions. Well, we know that during action potential at B, that's depolarization, that's when voltage gated sodium ion channels are open, so that's when it's more permeable to sodium. So the opposite is D, when the potassium ion channel, voltage gated potassium ion channels are open, so that's when it's going to be more permeable to potassium ions. Be careful, this says potassium, so that's point D. And then depolarization, well, D is repolarization, so therefore depolarization is the opposite. That's when the voltage gated sodium ion channels are open, so that is point B. Just make sure that you don't write more than one answer unless you're absolutely sure that they're both correct, because if you write an answer that contradicts or is wrong compared to your first answer, you'll get 0 marks. Each of these points are worth 1 mark each.